Good day. This is Awesome Yellow Corner, and today we will discuss about power series. Power series is an effective method of seeking a solution for a certain differential equation using power series in the terms of summation of Cn x raised to n, where n is equal to 0. In relation to our past topic, Laplace transform, it can be viewed as a continuous analog of a power series in which a discrete parameter n is replaced by a continuous parameter t and x as e raised to negative st. And now we will solve our first example of differential equation, solving this using our power series. And we have the values of our y prime and y double prime. We have our given y double prime minus 4y prime plus 3y is equal to 0. We have the value of our y, which is equal to summation of an t raised to n. We replace our variable cn by an and xn by our new variable t raised to n. And having the derivative of this equation, we have y prime, which is equal to summation of n a sub n t raised to n minus 1, where n is equal to 1. And our y double prime is equal to summation of n times n minus 1 a sub n t raised to n minus 2, where n is equal to 2. And substituting the values of y prime and y double prime to our equation, we have summation of n quantity n minus 1 a sub n t raised to n minus 2 minus 4 times the value of our y prime summation of n times a sub n t raised to n minus 1 plus 3 times summation of a sub n t raised to n, which is equal to 0. So we have substituted the values of y in our equation in terms of summation. And now, in order to evaluate this equation, we need to shift the indexes of each summation be equal to 0. And now we have balanced our equation by setting our n summation to 0. And since y double prime has an n equal to 2, we add plus 2 and plus 2 in order to subtract negative 2 in order to balance our equation and setting our n equal to 0. And minus 4 summation of n plus 1 a sub n plus 1 t raised to n be equal to n is equal to 1. And in order to balance our equation, we subtract 1 from our t and have it on our n. So we have n plus 1 and plus 3 summation of an t raised to n as n is equal to 0. And we have balanced our equation in which our indexes is equal to each other, which is 0. And we will factor it. We will factor the summation where n is equal to 0, having n plus 2 quantity n plus 1 times a sub n plus 2 t raised to n minus 4 quantity n plus 1 times a sub n plus 1 t raised to n plus 3 a sub n t raised to n. And the next step we will have is to factor our tn or our xn. Having this, we factor out our tn. This is our equation, which is equal to 0. And from the equation we can have n plus 2 quantity n plus 1 times a sub n plus 2 minus 4 quantity n plus 1 times n sub n plus 1 plus 3 an equal to 0. And from our simplified equation, we can now have our recursion relation. So we have a sub n plus 2 equal to 4 a sub n plus 1 over n plus 2 minus 3 n sub 1 minus n minus 2. And we have our recursion relation equation.